very warm welcome, my all dear friends. I'm Sunny Anand just before you again. Dear friends, we are just going to discuss about the capacitors and capacitance. Dear friends, first of all, we have to know what is the capacitor and what is the capacitance. After this, we will discuss a derivation, which is most important derivation according to me, according to your board purpose as well as your competition purpose. So let's begin this video. So first of all, what is the capacitor? Dear friends, capacitor is a system of two conductors separated by. Now, capacitor is a system of two conductors which is separated by an insulator. The system is known as capacitor. So we can take this plate and this plate. Suppose this conductor and this conductor, which is separated by an insulating material between this. Okay. So this system is known as capacitor. Again, a word is capacitance. Capacitance is a basic property of capacitor. But the weird fact about this is not depend upon Q, this is not depend upon V. Then first of all, we have to know that C is equals to Q upon V. Now we are just going to talk about how can we get this formula. Dear friends, suppose that we are giving some charge to this plate, this capacitor. So the potential between the conductors also increasing. So the increasement of charge of the capacitor is the result of the increasement of potential of the capacitor. Okay, means if we just suppose that if we give Q charge, there is potential is Q. If we give Q naught, so the potential will be V naught. So the ratio will be always same. So that's the reason C is independent of Q and V. If you looking this formula, you will be misled that C may be depend upon Q and V, but it's not reality. C is independent of V and Q. Now just we are going to talk about the derivation. Dear friends, we are going to derive capacitance with partially filled by dielectric. Okay, capacitance with partially filled by dielectric. Dear friends, just suppose this is a system, this is a capacitor, this is a plate. Okay, between this we take a dielectric, which dielectric strength is K and the thickness of this dielectric is T. Okay, and the distance between the plates are D. Now we know that E naught is equals to V naught upon D. So we can also write it V is equals to V. So we are going to split into two parts this volt, this potential, that is V vacuum plus V dielectric. V vacuum is this area and V dielectric is this area. Okay, so V vacuum is equals to E naught into D minus T plus E naught upon K. This is the E naught upon K is the electric field in dielectric into T. Okay, E naught will be common. This is simple calculation, you can easily solve it. So E naught is equals to, we will find this value, but we know that what is the value of capacitance, what is the formula of capacitance? Q upon V. We already discussed about this. So C is equals to Q upon V. And what is Q? Q is the charge on this plate. Q is charge on this plate. So suppose that the area of this conductor, this plate is A, and the charge density, surface charge density, sigma. Okay, so the charge will be Q is equals to sigma into A. Okay, so sigma into A upon V. What is the value of V? We have already taken this value. Just put it E naught D minus T plus T upon K. Okay. We also know E naught is equals to sigma upon epsilon naught. So sigma into epsilon naught, which is going to above denominator to numerator, that is E epsilon naught into d minus t plus upon t upon k. Okay, this will cancel out. We'll find c is equals to a epsilon naught d minus t plus t upon k. This will be the formula, means this is the standard formula. We can easily know that whatever size, whatever thickness of the dielectric we will take in, just we put in this formula, we will get the capacitance of that capacitor. Okay, so if you understand this video, please like, share, comment. Thank you very much, dear friends.